Okay, so we're going to use these formulas here to do a practice calculation. What is the activity coefficient for hydronium ion in a solution that is 0.1 molarity in sodium chloride? And the size of the hydronium ion is 900 picometer. So I'm going to use Excel to do this, okay? But you can always use calculator if you prefer using calculator. Okay, so first of all, I'm not going to share this template with you because I want all of you to set up your own Excel formula for this calculation. It's a practice of using Excel, but the video will be uploaded so you can follow the procedure. The first column, I have the concentrations of all the available ions. So my question for you guys first is, what are the available ions in the solution?
NaCl and H.
Na, so we have sodium, we have chloride, and you mentioned that we have hydronium. If you have hydronium ion, what else you should have? OH.
OH.
Yes. So that's about what we have. You can also write it as, I'm sorry. This way, it's the same thing with hydronium ion. Now, what is the concentration of each ion? For sodium chloride, it's given here, it's 0.1, right? So for sodium is 0.1, for chloride is also 0.1. What about hydronium and hydroxide? All right, so it is supposed to be a neutralized solution, right? Because we have sodium chloride, so it's about pH 7. Then you know that the concentration of hydronium should be about 10 to the negative 7. Now, if you're looking at this equation, of course, you're supposed to add all the ions together. But if you're looking at this value compared to this value, this actually can be ignored, right? It's much smaller than this value. And if you consider the uncertainty when you're doing the calculation, this actually doesn't affect the result at all because it is too small. So in this case, we only have to consider sodium and chloride. Does that make sense? All right, so the C1 is 0. Okay, before I put in any number, let me go over the formula I have here. This first column is the concentration of each ion, and you can set up more if you have more ions in the solution. So I have C1, Z1. Z1 is the charge of each ion, and same with the others. Now mu here is going to be the ionic strength we're going to calculate. So I have a formula for that. The formula is 1/2 of C1 Z1 squared plus C2 Z2 squared plus C3 Z3 squared, depending on how many different ions you have in the solution, okay? And then ZA is simply the charge of the ion of interest. In this case, it's hydronium ion, so it's simply 1, right? And for alpha, it's the size we're already given. Alpha is 900, okay? A negative logarithm of gamma is by using this formula. So we have in the numerator, we have 0.409 times C4 squared. C4 is the charge, right? And then multiply the square root of C2. C2 is the mu here, right? And the denominator, we have 1 plus alpha A, which is C6 here, right? And then divided by 305 multiplied by the square root of mu again, C2, okay? So this is how I set up the equation. And then because negative, you already see the negative logarithm of gamma, and then gamma can be calculated as 10 to the negative of D2, right? It's just anti-logarithm, okay? So now let's start putting in the numbers. We have, as I said, you only have to consider sodium and chloride. So we put 0.1, C1, the charge is 1, and C2 is also 1, charge is also 1, okay? And you can see that the mu can be calculated as 0.1, and after you put all the number, it's actually the equations do the calculation for you and returns with a gamma, which is about 0.83, right? Because we have two sig figs, so we can assume it's 0.83. And if you really want to try out with the other concentrations, you can definitely do that. This one will be 10 to the negative 10e negative 7, right?
Professor?
Yeah?
Wouldn't it be 1 sig fig due to the 900 PM?
900 PM, well, it's a tricky part. So it could be 3 sig fig, it could also be 1. We didn't specify it here. So I'm not going to be very critical about the sig fig here. Yeah.
Okay.
So you can see if I put the concentration of hydronium ion, it actually didn't change at all, right? Because as I said, this concentration is much smaller than the concentration of sodium chloride. So it can be neglected during your calculation, all right? Do we have any questions here? Okay, so when you go after the lecture, please set up your own formulas for this equation. It will make your following calculation much simpler compared to have to putting in the number into calculator every time. Okay, if no more questions, I'm going to move forward. So if you still remember, the value we got is 0.83, right? And you can actually find in the textbook, there is a table showing the activity coefficient for some typical ions under different ionic strengths. So the example we just did is for hydronium ion. The ion size is 900, and the ionic strength we had is 0.1 molarity. So it's 0.83. So our calculation shows the same result with the table. Okay, you can go ahead practice with other concentrations or other ions, and then compare with the table to double check the formula of your Excel sheet.